right. So for Algebra 2 today, we're going to finish up this I don't even remember. 6, right? Okay. Because we need to focus on simplifying, like with all the things that we've had to do. I know, right? And so it's kind of a good way to come back is just like work on doing some of that. So some polynomials can be written as quadratics and then factored using the previous methods that we've used. So we want to always factoring a common factor from several groups may reveal a common binomial factor. Okay, so if we look at this first one, we want to factor the a and b here. The first one has 3 terms. So we can look at it first. What should we do? Like, what do you think we do when we have 3 terms? Like, what do you think of as like its standard form? Okay, trinomial form, which would be that ax squared, yeah, plus bx plus c.
I was trying to take a stab at the dark and I got something.
Hey! You know, you might not have hit the target, but I mean, like, yeah, you hit the target for sure. I mean, you almost hit the bullseye, man, with it. Okay, so that's that standard form for a trinomial. So what do you notice is wrong with what we have versus what is standard form? The descending thingamajig, okay? So the exponent, okay? So you're going to get so trippy. Okay, this has an x squared, right? This one has an x to the 4th. Is there an x squared buried in there? Okay, so this can be written as like, this is actually the quantity x squared squared. Yeah, because 2 to the power of 2 is going to be 4 minus 5x squared is the quantity, and then plus 4.
But then it's still not in descending order.
Actually, it is in descending order now.
Because it's all 2s.
Well, because it's this term squared, and then it's this term to the power of 1, and then there's no term. Yes, because I used the parentheses. So the thing that's inside the parentheses is my new term.
So just because your term, what's inside your term is squared doesn't necessarily mean the whole term itself is squared.
Say that again.
Just because the x inside your parentheses, which is like a component of your term is squared, doesn't necessarily mean the whole thing is squared, which means that you can't do that.
Right, like you mean like the 5.
Just to the power of 1.
Yes, yes. Okay, so now that that's the case, we've got it in this lovely form. So we do have it in this quadratic form now, or that standard form. Okay, we can factor. Okay, so what are the factors of 4 that get me a -5? Or we have to check to see if we can factor, I should say. Are there any factors of 4 that get me -5? -4, good, times -1 equals a +4. So check, right? That's what we wanted, was a +4 here. -4 plus -1 gets me -5. So that's a check because that's what we want here. So what is my term? No, I'm not the president. Oh, look at that. Okay, so my term is the x squared. So previously when we did this and we just had x's, remember we would say, well, x minus 4 times the quantity x minus 1, right, to factor. But my term isn't x anymore, it's x squared. So this is just going to be x squared minus 4 times the quantity x squared minus 1.
So which ones did you pull out? Just the x? Like you only pulled out the x squared because the other 2 numbers are... Give me a refresh.
Okay. You're good. I was saying, we've had spring break. I get it. Okay. So if... Yeah, we're just factoring. So if we had, like, say this was b squared plus 5, or minus 5b. Let me rephrase. If I could find my eraser. I found it. Yeah, I was like, but now it doesn't want to find me. There we go. Okay, so if this was b squared minus 5b plus 4, okay, we would find the factors of 4 that equal negative 5. So that was the negative 4 and the negative 1. Okay, so when that's the case, then we would say, well, this is b minus 4 times the quantity b minus 1, and we were done factoring.
So your variables are always going to be the same, right? The exponents of the thing's going to be different. Like it's always going to be b, or is it going to be like x?
No, they'll never be. Whatever variable is used here is the variable we use here. Yeah, which is why here what we had was what was being squared was our x squared. That was our term. So instead of having x minus 4, it was x squared minus 4.
So if you were to write it like that, that x squared squared minus 5 times the quantity x squared plus 4, if you have to write it like that, your variable always has to be x squared. And if you have like x squared, just x, it won't work, right? Because your variables have to be the same.
Right, right. Yes. Yeah. The variable, or we're going to call that the term because it's the variable and something else. So the term.
Did I just hear a little kid talking?
Maybe there's one here somewhere. I think Chad's daughter, maybe. Okay, so I'm going to rewrite this up here a little bit. So we've got x squared minus 4 times the quantity x squared minus 1. Okay. Now, the reason I rewrote it is because we're not done yet. Because if I look at this, do you notice anything special about these? They don't match. They don't have to, just like these don't have to, right? Our pink ones, they don't have to match when we're done. But if we're simplifying it all the way, like we're going to factor it and simplify it as far as we can go, we're not done yet. How can I? Well, that is an idea, but we can't pull out an x out of both of them because there's not an x term with the 4 or the 1. Okay, so when we have just two terms and one of them is squared, we need to think about like, is this a difference of squares problem? Okay, so difference of squares means subtraction. And am I subtracting two squared numbers? Okay, so like, does, well, this is x squared minus, is there a square root to 4? Does 4 have a square root? What is it? Okay, so this is actually x squared minus 2 squared. And the other one, we have x squared minus, is there a square root of 1? Yeah, 1 is the square root of 1. So this is the same thing as 1 squared. Yeah, but the x's already have x squared. Right? It's already written as x squared. I'm just rewriting the number so you can see like, hey, this is a square number as well. So we see it is the difference of squares. I have a square number minus another squared number. So if I had 25 minus 16, that's a difference of squares because this is 5 squared minus 4 squared. Okay, so we're just putting it where we see the square, trying to take that time out. Yep.
Wouldn't the sign change to a plus Never mind.
Okay, so this is a difference of square problem. These both are actually, I should say. Okay, so these are difference of squares. So we can factor them further. When we factor a difference of squares, we take each term, and so it's going to be x minus 2 times the quantity x plus 2 when we factor them. So this is one of those like special cases that we've talked about in the past to know. But so you kind of have to go back and look at those. I maybe should have whipped up a sheet to help you guys. I might do that while we're working on homework if we have time. this answer from here? Because I know when I have a difference of squares, usually it's, let's see, we would say a squared minus b squared is a difference of squares equals the quantity a minus b times the quantity a plus b. Like they give you that formula. Just like right before we left, we worked on the cubes in this notes, the sum and the difference of a cube. We were given the difference of squares previously.
So that's that x minus 2, x plus 2, that's only the answer to that first. We have to do it again.
Yeah, we have to do it again for this one because it's another one.
It's just going to be x minus 1 and x plus 1.
You got it.
So then when you do it that,
Now you're finally finished.
you have 4 terms.
You have 4 terms, but you have factored each of the 4 terms.
So that's giving you a list of possible factors, right?
Yep.
For your original.
Yep. You got it. We factored it as far as we could factor it. So like if we wanted to take x to the fourth minus 5x squared plus 4, we could do some synthetic division. And so we could divide by x minus 2, we could divide by x plus 2, x minus 1, and x plus 1.
And those are the ones that are going to give you like the outer remainder, right?
Yep, those are all the ones that we get without a remainder.
You could divide by anything else, but you would have a remainder.
Yep.
So that just gives you a list of ones that will divide even.
Correct. You got it. So yeah. So not the, I get it, it's not the funnest thing. It's kind of tedious to factor it all the way, but that is what we were practicing, working on today.
Could you do it if it wasn't a difference of squares? Like, is there a difference in it?
If it was difference of squares?
If it wasn't.
So there are other ones, like there's the difference of cubes. If it's just a trinomial that you can factor.
If it's not one of those special cases, then you're just done. But if it is a special case, you can go farther.
Yeah, and that's it. You're just gonna have to kind of piece together. Is there, like, think about, is there more? What else can I do? Is this a difference of squares? Is it a difference or sum of cubes? Like, does it?
So is it always gonna work out to where it's gonna be one of those special cases, or is
Nope.
there some where they're just you're done?
There are some that you're gonna be. Most of these are gonna go like require 2 steps, which is the ones that I picked for us to do. Are going to require at least 2 steps. Otherwise, we've already done the others. But previously, we have gotten to a certain point. We're like, okay, we're going to stop here because that's what we were learning at this point. And so now we're bringing all the things back to take it even further. So this one, what do you notice about B if we look at B? Whoops.
They are not in descending order.
They're not in descending order. Anything else about B? Ooh, they are in descending order. You're not dumb. So it goes 3, 2, 1, and none.
You had me thinking I was dumb.
Anything else about these two, though? Or this about B? How many terms are in B? 4. How many terms were in A? This is not a trinomial. So it's a polynomial. I like it. So it's a trinomial plus 1.
Actually, it's plus 45.
So we actually it's plus x cubed. Yep. Quadratic. Anyway, so in this case, we are going to do some grouping. We can't, because do the 4 of them, actually, is there anything we can factor out of all 4 of them? No, because that's the first thing. We always want to say, like, can we factor? No. Since we can't factor, well, we can say, well, let's force some factoring. We're going to group our numbers this way. We're going to look at them as 2 terms together, so as binomials. Can we factor anything out of the first binomial, x cubed minus 5x squared? We can factor out an x squared. Absolutely. So we're going to factor out x squared, which is going to leave us with x minus 5. Perfect. Can I factor anything out of negative 9x plus 45? Okay, we usually always want to take, if there's a negative here, we want to take the negative 9. Okay, so negative 9 is going to leave me with x minus 5. Well, that was kind of sweet. What do you notice now? Okay, they have a common, right? from several groups may reveal a common binomial factor. That's what we have here. X minus 5 is that common binomial factor. So then we could say, all right, now I've got x squared minus 9 times the quantity x minus 5. So if I look at this, I'm like, okay, x minus 5, I can't factor anything else right. It's down to a term of x and a term of 5. How about the x squared minus 9? Can I do anything with it?
Yeah.
Just move so that look doesn't hit me.
Move so that look doesn't hit you.
Yes.
Yes. Okay, so because it has, like again, we have an x squared in here and we have two terms, we have to wonder, is this a special case? Like, is it a difference of squares?
Where did the 9 come from? You had 5, 9.
There's where the 9 came from. Remember, because we combine those two in their own term.
Oh, yeah.
Okay. So, is there a square root of 9? If there's not, we are done. But is there a square root of 9? There's not a cube root of 9. Right, but that's not what cube roots are. Or square roots and roots are when you multiply a number by itself, right? Like 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9. 9 is a square root. 9 is not prime. Like you said, like 3, 6, 9. But your squares are 1, 4, 9, 16, 25, 36, 49, 64, right? 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49, 8 times 8 is 64. Okay, so those are your squares. So if you have any of these numbers, then you do have a square root. So this is x squared minus 3 squared times the quantity x minus 5. So it's a difference of squares. Yeah, the other one isn't, but that one, this first one, x squared minus 3 squared is. So how would we split that up and factor that one further? You got it. X minus 3 times x plus 3. And then we need to just bring the other one down. So that's...
So you can do just one.
You can do just one of them. And then now you have all of the factors. 3 possible ones. Yep. You got it. So that's it. And I have a worksheet for you today. It is only 8 problems. But they are some time-consuming ones.